welcome back to Drawing Hub. So this is Python Programming Module 1, Part 4. Now, mixed mode arithmetic and type conversion, which we were supposed to cover in the previous video, but since it was a lengthy one, we have to bring it back to Part 4. Now, mixed mode arithmetic and type conversion. Performing calculations involving both integers and floating point numbers is called mixed mode arithmetic. Okay, mixed mode arithmetic means, so from the word itself it is clear, mixed mode. Mixed, it has two or more components. Arithmetic related to maths. So here, when you look at the example, 3.14 into 3 power 2, double exponents, double asterisk sign indicates exponential. Okay, so now 3.14 here, this is a floating point number, and 3 and 2, they are integers. Now when we get the answer 28.26, we get it as a floating point number because we have a float over here. Okay, now you must use the type conversion function when working with the input of numbers. So if we want to get the input of numbers, see, by default, as I told you before, by default when we are inputting, we get it as string. So we have to convert it into the number we want, let it be integer, floating point, or anything else. Now that is why we need to use type conversion, which I have discussed in the previous video. Now our type conversion function is a function with the same name as the data type to which it converts, because the input function returns a string as its value. So this is something we have already discussed. Now we must use the function int.float to convert the string to a number before performing arithmetic. Now here, as I told you about the radius, remember? Okay, so radius is equal to input, enter the radius. So now when we get here, we are asking the user to enter the radius. Here this is in the form of a string. See, radius equal to input. I have not used any type conversion functions over here. So I'm directly getting it as a string over here. So enter the radius, the user enter the radius is 3.2. And when we are asking to print the radius, see over here, you see the single quotation mark? That is, which indicates it is a string. Now I am converting it. I am using float radius. Now when we are asking to print it, 3.2. This is the number. The float radius power 2 into 3.14. So float radius, now it is a number. So this calculation will be performed. And after evaluating, you get the answer, 32.153600004. Okay. Now another use of type conversion occurs in the construction of strings from numbers and other strings. So for constructing strings, a number of other strings, that is what use type conversion. That is another use of it. Now profit is equal to 1000.55. So I have assigned a value. You remember what this equal to operator is. It's an assignment operator, right? Equal to, so this value 1000.55 is stored in the variable profit. And now I am asking to print dollar plus str profit. So now here I want it as, see, here by default it is an floating point, it's a number, but here when I want to print it, I'm asking this profit to be a string. So when I get it printed, it will be $1000.55. That's a string. Python is a strongly typed programming language. The interpreter checks data types of all operands before operators are applied to those operands. If the type of an operand is not appropriate, the interpreter halts execution with an error message. Okay. So Python is a strongly typed programming language. Now the interpreter will check all the data types of all the operands before operators are applied to those operands. Now if the type of an operand, the interpreter will check if all the operands are of the same type. Now if it is of not an appropriate one, the interpreter will halt the execution and will display an error message. Okay. Now using functions and modules, which is very important. Now functions, we do all the programming with function because that is a very easy way to implement. Now, using functions and modules, Python includes many useful functions which are organized in libraries of code called modules. Okay, so there are libraries, and from these libraries we get the modules. Now, a function is a chunk of code that can be called by the name to perform a task. Function often require arguments that is specific data values to perform that task. So what is function? It is a chunk of code. It's a set of code, and we call it by its name so that it can perform a task. We'll see how to do a function later. Names that refer to arguments are also known as parameters. We have parameters, we'll see that. The process of sending a result back to another part of a program is known as returning a value. Now there is this process, we take the result and we send it to another part of the program. So that process of sending the result to another part of the program is known as returning a value. We'll see with examples. Now here round 7.563 and 2. Okay, so what is this 2 over here? Comma 2 means round it with 2 decimal values. So I'm when I returned will be 7.56. ABS 4.4 minus 5, so returns 1. So these are above built-in functions. The built-in, it belongs to the built-in module. These are functions which belong to the built-in module. Then there is another module called the math module, which we use it pretty often. The math module includes several functions that perform basic mathematical operations like sine, square root, tan, and all those. The list of function names includes some familiar trigonometric functions as well as Python's most exact estimates of the constant pi and e. So pi e, sine h, square root, tan h, truncate, etc. They all are used. Now syntax for using specific function from maths module. So first, how do we call the maths module? So the math module, first we import math module, then math.py, and then we will get, so we just have to write math.py and the whole thing, because pi is already in there inside the math module. You can actually check that. Okay, we're here. Import math and math.py. Now I'm executing it over here. Okay, so here math.py, and I got it as, I got a lot of decimal value, but that doesn't end over there. And now that I have printed the pi, I'm asking the square root of, okay, now I have done this. Now I'm asking the square root of math dot square root of 2. Okay, look, see here I have already imported math, that's why I did import it again. And now here it is. Now what will happen if I don't have that? We can check that. I don't have this, so I'm deleting this. Okay, and I'm deleting this too. And now I am asking it to, see, I haven't imported it, so it will not come. It's already showing an error. See, yeah, this is because I have already uploaded it. Now we can reload it and check it later. Okay, now to import specific function, now if we need to import certain specific function, we can use from math import pi square root. So from the math module, I want to import pi or square root, like that. So at that time it will be a little much more easier. Math dot. Now I'm asking it import math. I have imported math. Now we don't have to do that because we are asking for specific thing. So from the math module import pi. That is what we have to do. So what will we do? From math module import pi. Okay, I have imported pi, and then we can actually print pi without asking for it. We just have to print the pie and we don't have to use mat.py as we have did before. Now to import all of the math modules resources, we can use a asterisk sign. So from math import and the start sign. So we'll get all the modules inside the import. Now program format and structure. Let's start with an introductory comment. We have discussed how we should distinguish between comment. We have end of line comment and docstring. I hope you remember, we have already discussed in the previous video. Stating with the author's name, the purpose of the program and other relevant information. This information should be in the form of a docstring. Then we can include statements such as we can import. It's the structure of how we do the program. So import any modules needed by the program, initializing important variables suitably commented. Now prompt the user for input data and save the input data in variable. Process the input to produce the result, display the result. So this is just a structure, we'll look that later. Control statements. Statements that allow the computer to select an action to perform in a particular action or to repeat a set of actions. We need to repeat. Now there are two types of control statements, selection structure and iteration structure. So first one we'll look about iteration structure. So what is iteration? Iterate, repeating, loops. So we call iteration structure also as loops which repeat an action. It keeps on repeating. That's why it's called iteration. Each repetition of the action is known as a pass or an iteration. So every time this repeats, the chunk of code repeats, it is what we call as a pass or an iteration. Now there are two types of iteration. Those that repeat an action a predefined number of times, definite, and those that perform the action until the program determines that it needs to stop. So first we'll say you have to go this much number of time. It is predefined. So it will go at that much number of time. It is definite. And then there is indefinite iteration. That is till the program asks it to stop, it will keep on going. So that is definite and indefinite iteration. Next we are having the for loop. The control statement that most easily supports definite iteration. So the for loop is very important and it actually easily supports definite iterations. For loop is for definite iteration. The form of this type of loop is, how do we do? So this is the syntax for loop. We have for, that is a keyword, and then we can include a variable identifier, and in. So in Python it is different from C. For variable in is a keyword and we write range, and then we have any integer expression till how much it have to iterate. Then we have the colon, statement 1 to statement n number of statements we will have. So for is a keyword, for the variable in range, an integer expression, colon, and n number of statements. The first line of code in a loop is sometimes called the loop header. The first line of a code. So inside a loop, whatever is the first line, that is what we call as the loop header. Now integer expressions in the header denotes the number of iteration that loop performs. So here we have said there is an integer expression, and this integer expression in the header, so this is called the loop header, and this integer expression in the header denotes the number of iteration. So how many iteration that the loop will have to perform, that is what this integer expression denotes. Now the colon ends the loop header. So when there is this colon, we tell that the loop header is over. The loop header is over. The loop body comprises the statements in the remaining lines of code. The loop body comprises the statements in the remaining lines of the code. So we said our loop header, loop body, the remaining statements. So we have this n number of statements, that is loop body. Note that the statements in the loop body must be indented and aligned in the same column. So now we have a condition. So if you have noticed over here, we have the colon and the statement 1 doesn't start all the way from the left side. It have one tab space. We can use one tab space, 2, 3, 4, but minimum we should have one. And statement n is also in the same place. We can't put statement 1 with 1 tab space and statement n with 2 tab space. Then that will be an error, indentation error. So what we will have to do? Should be in the same space. So indentation is very important. Note that the statements in the loop body must be indented and aligned in the same column. These statements are executed in sequence on each pass through the loop. Now we are having this question. 4 is a keyword. For each pass is my variable name in range 4. So I wanted to repeat how many times? 4 times. Colon and see the tab space over here. Print. It's alive. And I'm using end. Why do we use end? Because we want the output to continue in the same line. We don't want it to go to the next line. Now what will happen if we don't use the end over here? The output, it will go one after the other. It will continue in number of lines. So here it's alive. So what actually happens over here? So for each pass in range 4, the code will come over here and then it will print it's alive with a space. Now it will go back again. So it will go back to the loop because it has only done 1 times. Okay, so it has only done 1 times. Now it will go up here. It will do it for the second time. It will go to the loop. Then for the third time and the fourth time. And when it have completed the 4th time, the loop will be okay. I have completed 4 times. Now I can come out of the loop, and it come out of the loop, and that's why 4 times it's alive is there. Now we have another example. Okay. Now in this example 2, Python's exponentiation operator might be implemented in a loop. So we want the exponentiation operator to be implemented in the loop. How do we do? So simple program, right? So I am assigning a variable number with 2, exponent 3, product 1. Okay. For each pass in range, so this is the syntax. For each pass is my variable in range. So what is the range? 3 times it have to go because that is the exponent. Colon product. Product I have defined it as 1. I have initialized it as 1. Why didn't I give it as 0? Because if I put 0 over here, 0 into any number will be 0. So it will display as 0 only for the whole time. That is why I have initialized it as 1. So product equal to product into number. So whatever product I am getting, that into number. And I have to print the product. So number 2 have to be printed 3 times. So that is the exponent. 2, 4, 8. And what is the product? I will get it as 8. Further explanation of the code, I will do it towards the end of the module. So this is just based on theory. Then we have another example which we'll look in the next video.